Hello and welcome to Lucid Mind Chemistry channel with Majid. In this video, I'll be solving Chemistry O-Levels Alternative to Practical Paper 42 from May-Jun 2020. You can go to any particular question by following timestamps given in the video description. Let's start. Question 1. Iron tablets are used to treat iron deficiency in the body. Iron tablets contain iron 2 ions, which is iron plus 2. A student does a series of titrations with aqueous potassium manganate to determine the percentage of iron in some iron tablets. Diagrams of some of the apparatus the student uses are shown. These are the apparatus diagrams. Part A. Name the three pieces of apparatus. We can look at the apparatus. Apparatus A is burette, so we can write burette. Apparatus B is measuring cylinder. You can also write graduated cylinder. Apparatus C is pipette. Part B. The student records the total mass of 5 iron tablets, crushes the tablets, dissolves them in water and makes the solution up to 250 cm cube. Then he uses apparatus C, which is pipette, to transfer 25 cm cube of the solution from this 250 cm cube of iron plus 2 into the conical flask. Then he uses apparatus B, which is measuring cylinder, to add 10 cm cube of dilute sulfuric acid to the conical flask. Then he fills apparatus A, which is burette, with 0.005 mole per decimeter cube potassium manganate aqueous. Then he titrates the solution of iron plus 2 with 0.005 mole per decimeter cube KMnO4 aqueous until the first permanent pink color is seen in the conical flask. Repeats the titration 3 times. The equation for the reaction is shown. This is MnO4 negative manganate potassium manganate. This is iron plus 2, which is titrated with this potassium manganate, and manganate is itself reduced to Mn plus 2 and iron is oxidized to iron plus 3. Now the color of manganate before titration is purple, and after it is reduced to Mn plus 2 it becomes pink. Part 1. Suggest why dilute sulfuric acid is added to the conical flask. As we can see in this equation, H plus ions are present that help in this chemical reaction. So acid is actually added to provide H positive ions. Part 2. Give the formula of the ion responsible for the pink color seen at the end point. Now manganate is the purple solution that is responsible for the pink color, so we can write MnO4 negative. Part 3. The diagram shows parts of apparatus A with the liquid levels at the beginning and end of titration 3. This is titration 3, this is the initial reading, and then we have final reading. In initial reading we can see that the value is, we always go from top to bottom, so it is 0.0. Then we have this as 0.5, 0.6, 0.7. And in final reading we can see that it is 17.1. Record the values in the results table. Complete the results table for each titration 1, 3 and 4. In titration 3 we have final reading as 17.1 and initial reading as 0.7. So in place of final reading we can write 17.1 and initial reading is 0.7. Now we can find the volume used. 17.2 is the final reading and initial reading was 0.0, so we can subtract both of these and the reading is 17.2. Similarly we can subtract these two to take this reading, and we can subtract these two to take 16.4. Then 16.9 is the final reading and volume used is 16.7, so then initial reading must be 0.2. This can be obtained by subtracting these two values. Now we have to find the best titration results. Best titration results are always those that are nearest to each other. So we have 17.2, 16.9, there is a difference of 0.3. Then we have 16.4, there is a difference of 0.5. And we can see between 16.9 and 16.7 there is only a difference of 0.2. So the least difference is between these two values. So these two are the best titration results. Part 4, tick the best titration results in the table. We have already done that. Use the ticked values to calculate the average volume of 0.005 mole per decimeter cube KMnO4 aqueous used. Now average volume can be found by adding these two values together and dividing by 2. We have 16.7 and 16.9. We can find the average. So average volume obtained is 16.8 centimeter cube. Part C, a second student does another series of titrations using the same method and 0.005 mole per decimeter cube KMnO4. This student obtains an average volume of 16.9 centimeter cube. The equation for the reaction is shown. This is the equation. Part 1, calculate the number of moles of MnO4 negative used by the second student. Now the formula of moles is, we can find out the formula by using concentration, as concentration in mole per decimeter cube is equal to number of moles divided by volume in decimeter cube. So number of moles is equal to concentration in mole per decimeter cube into volume in decimeter cube. Now we have 16.9 centimeter cube as volume. We can change it into decimeter cube by dividing by 1000. Concentration is given as 0.005 mole per decimeter cube. So we are going to use this value. So 0.005 into 16.9 divided by 1000. The number of moles come equal to 0.0000845 moles. So these are the moles of MnO4 negative used by second student. Part 2, calculate the number of moles of iron plus 2 ions present in the 25 centimeter cube sample of solution. According to balanced equation, 1 mole of MnO4 negative requires 5 moles of iron plus 2 for complete reaction. So therefore we can take the ratio between these two. We have iron plus 2 and MnO4 negative. From balanced equation, the number of moles ratio is 1 to 5. Now we have 0. This much moles of MnO4 negative. So we can find the moles of iron plus 2 by cross multiplying. So the number of moles of iron plus 2 will be 0.0000845 divided by 5, which is equal to 0.0004225 moles. So we can write this as answer. Part 3, calculate the total mass of iron plus 2 ions in the 5 tablets. Atomic mass of iron is given, it is 56. In the question we can see that 5 iron tablets were crushed and dissolved to form 250 centimeter cube, while we have the number of moles from 25 centimeter cube iron solution. So first we are going to find the mass of iron plus 2 in 25 centimeter cube sample. Then we are going to find the total mass of iron plus 2 in 250 centimeter cube sample, as 5 tablets were crushed to form 250 centimeter cube solution. The formula is mass is equal to moles into molecular mass or atomic mass in this case. Number of moles is 0.0004225. Atomic mass is given, it is 56. So mass in gram of iron plus 2 in 25 centimeter cube comes equal to 0.0237 grams. This is for 25 centimeter cube. So then for 250 centimeter cube it will be, we can write for 25 centimeter cube it is 0.0237 grams. So for 250 centimeter cube it will be x. By cross multiplying, we can find the value of x. Now the total mass of iron plus 2 in the 5 tablets is equal to 0.237 grams. Part 4, the total mass of 5 tablets is 1.83 grams. Calculate the percentage by mass of iron in the tablets. Gives you answer to 3 significant figures. The mass of iron obtained was 0.237 grams while the total mass was 1.83. So we can find percentage by mass. Is equal to mass of iron plus 2 in 5 tablets divided by total mass of 5 tablets into 100. Now we can put the values. 0.237 grams divided by total mass, which is 1.83 grams, into 100. Percentage by mass comes equal to 12.95%. Now we can write the answer to 3 significant figures, which is 12.9. Question 2, Part A. A solution contains one cation and 2 different anions. The table shows the tests a student does on this solution. Complete the table. Name any gases that are formed. Now this is a table of cation and anion identification. First test is that to a portion of this solution, a boiling tube, they added aqueous sodium hydroxide. And the conclusions is that the solution contains iron plus 2 ions. Now we have to write the observations. We know that iron plus 2 is green in color, so therefore green precipitate of iron plus 2 is seen. So in observation we can write green precipitate. Part 2, to a portion of solution in a test tube, add dilute nitric acid until no further change is seen. Keep the solution for test 3. Observation is that a gas is evolved that turns lime water milky. Now we know that the gas that can turn lime water milky is carbon dioxide gas. And carbon dioxide is only produced from carbonate anion. Carbonate anion in the presence of acid, which is H+, it forms CO2 and H2O. So in conclusions, we can write that gas is carbon dioxide and anion is carbonate anion. Part 3, add aqueous barium nitrate. When barium nitrate is added, a white precipitate forms. As in the solution, we had 2 different anions. Now barium makes white precipitate with sulfate anion because barium nitrate is soluble and barium sulfate is insoluble. So in conclusion, we can write that the solution contains sulfate ions. Part B, calcium ammonium nitrate. We have calcium ammonium and nitrate is a water soluble compound. Describe a series of tests and the observations to identify calcium, ammonium, and nitrate ions in sample of calcium ammonium nitrate. Your description will need to explain how to prevent ammonium ions interfering with the test for nitrate ions. First things first, we have this water soluble compound, so we are going to dissolve this salt in water. Now when dissolved in water, we have calcium plus 2, ammonium plus, and nitrate ions are also present. First we have to find out the tests for calcium plus 2. For calcium plus 2, we know that if we add aqueous sodium hydroxide and warm, then white precipitate is formed that is insoluble in excess, which confirms the presence of calcium plus 2. So we can write add aqueous sodium hydroxide and warm. Then observation is that white precipitate is formed which is insoluble in excess. And it confirms the presence of calcium plus 2. Second test is for ammonium. For ammonium ions, we can do the test by adding aqueous sodium hydroxide and warming. And then the gas that is produced from ammonium ion is ammonia gas, which turns moist red litmus to blue, and it confirms the presence of ammonium ion. So we can write add aqueous sodium hydroxide and warm. Then the gas that is produced, it can be tested. With moist red litmus paper. It will turn blue. It confirms the presence of NH4 plus. Now third ion present in the solution is nitrate, so we can write test for nitrate ion. Now we have a problem, which is that ammonium ions are also present along with nitrate ions, so both these ions produce ammonia gas upon test. So first we are going to remove ammonia from ammonium ions, and then we are going to test the ammonia from nitrate ions. So we can add aqueous sodium hydroxide. We are going to repeat this process in order to remove ammonia formed from ammonium ion. So we are going to Add aqueous sodium hydroxide and warm until all of the ammonia is released. So the ammonia from ammonium ion has been removed. Then we are going to do the next step for identification of nitrate ions. We can add aluminum and warm. Then we can test the gas with moist red litmus. Which will be turned to blue. It confirms presence of nitrate ion. In this way, we can prevent ammonium ions interfering with nitrate ion and we can test for nitrate ions. Question 3 Part A. Name the process used to separate ethanol from a mixture of ethanol and water. State why this process is suitable. Now we have a mixture of two liquids, one is ethanol and one is water, and ethanol is also soluble in water. So therefore the process used will be fractional distillation. And this process is suitable because the boiling point of ethanol is different from the boiling point of water. Ethanol boils at about 78 degrees centigrade while water boils at around 100 degrees centigrade. So therefore these two can be separated by fractional distillation. So we can write both have different boiling points. So ethanol will be removed first. Part B. Describe a suitable method in each case to separate the named substance from the mixture. Explain your choice in each case. First is pure dry sodium chloride from a mixture of sodium chloride and sand. Now we know that sand is insoluble substance, that is insoluble in water, while sodium chloride is highly soluble. So first we can add these two in water and dissolve. By stirring. Then we can heat to dissolve all of sodium chloride and filter this solution. After filtration, the sand will be left behind on filter paper while sodium chloride solution will go through the filter paper. So we can say that sand is residue. And salt solution is obtained as filtrate. Now we can heat this filtrate, which is salt solution, by evaporation to dryness, and we can obtain pure dry sodium chloride. Part 2. A food coloring from a mixture of 3 food colorings. Now food colorings are pigments, and pigments can be separated by using the process called chromatography. This question is of 3 marks and then we have to find out 3 different points. In the first step, we are going to put this pigment mixture as a spot on chromatographic paper. In next step, we are going to put this chromatographic paper in solvent in such a way that the solvent level should be below spot level. So we can write, take solvent in a beaker, and put this paper in that solvent. In such a way that the spot should be above the solvent level. This is because if the spot is below solvent level, it will directly dissolve in the solvent, which is not required. We have to separate the spot, so therefore it should be above solvent level. Now we would see that each pigment would travel different distance, so we can find the value, that is RF value, for each pigment. And each pigment will travel different distance. So each one would have different RF value. Question 4. A student suggests a method to prepare pure dry crystals of hydrated copper 2 sulfate, but some processes are missing. In step 1, he measures a known volume of 0.5 mole per decimeter cube sulfuric acid into a beaker. Then in step 2, added a spatula measure of solid copper 2 oxide and stir. In step 3, heat to evaporate all the water and obtain the crystals. There is a process missing between steps 1 and 2 to increase the rate of reaction. Identify the missing process. Now in step 1, sulfuric acid is added. In step 2, copper 2 oxide is added into sulfuric acid. Both will react to form salt of copper and water. Now the rate of reaction can be increased by heating or warming gently. Part B. In step 2, all the solid copper oxide disappears. State and explain what the student should do in step 2. Now in this reaction, copper 2 oxide is insoluble and sulfuric acid is a soluble substance. Copper 2 oxide will react with sulfuric acid. Now we must see that the sulfuric acid should not be in excess. So in order to remove all the sulfuric acid, we should add excess of copper 2 oxide into sulfuric acid until all the copper oxide has been reacted. So we can say that we have to keep adding copper oxide until it is in excess. Or you can also say that as copper oxide is black in color, so you can say that until black solid remains. It means that all of sulfuric acid has now reacted. So we can say that this will react with all the acid. Part C, there is a process missing between steps 2 and 3. Identify the missing process and explain why it is important. Now we can see in step 2, a spatula measure of solid copper 2 oxide was added and stirred. In step 3, it was heated to evaporate all the water and obtain the crystals. Now as we can see that copper oxide is in excess and it is insoluble, so first we should remove this copper oxide by filtration. So we can write the missing process is filtration, and it is important because it is used to remove excess copper oxide, which is insoluble. Part D, step 3 will not make crystals of hydrated copper 2 sulfate. State and explain how the student should change step 3 to make pure dry crystals of hydrated copper 2 sulfate. In step 3, we can see that the student heated to evaporate all the water and obtain crystals. Now all the water should not be evaporated. For crystallization, the solution should be heated until it is saturated and then it is left to cool to make crystals. So we can write, he should heat the solution until it is saturated. The next step is to cool down the solution or leave the solution to cool. And the solvent will evaporate slowly. Then dry crystals can be obtained on filter paper. Part E, describe 2 observations the student makes during the preparation of pure dry crystals of hydrated copper 2 sulfate. For each observation, make clear at which step it is seen. Observation means the color changes. In observation 1, we can write that in step 2, what happened that copper oxide black solid was seen and it remains because it was added in excess. In step 3, we can see that blue crystals are seen which were of copper sulfate. Part F, state a hazard involved in this preparation and safety precaution the student should take to reduce the risk from this hazard. Now safety precaution can be because of some harmful chemical. In this process, acid was used. So acid is corrosive. So the student should use gloves or goggles should be used. Question 5. A student does an experiment to determine the enthalpy change, which is the energy change for displacement reaction between zinc and aqueous copper 2 sulfate. Zinc is more active than copper, so it will displace copper to form zinc sulfate and copper solid. State what is observed during this reaction. Now in this process we can see we have 2 different observations. One is of copper sulfate, which is blue solution, and it converts into copper solid, so therefore blue solution becomes paler blue or it fades. So we can write or it becomes colorless. In second observation, we can see that copper solid is formed which is of pink color. So we can write pink solid is obtained. Part B, the student weighs a sample bottle with small amount of zinc powder, pours 25 cm cube of 0.5 mole per decimeter cube copper sulfate into a glass of beaker and records the temperature. Records the temperature of copper to sulfate at 1 minute intervals for 3 minutes. Then he adds the zinc powder to the copper sulfate aqueous at 4th minute and reweighs the sample bottle. Then stirs the mixture in the glass beaker and records the temperature at 1 minute intervals for 6 minutes. The masses recorded are shown. Mass of container with zinc powder is given as 15.18 grams. Then mass of container after zinc powder added to copper sulfate is 14.23 grams. Part 1, calculate the mass of zinc powder added to copper sulfate aqueous. This is easy, we just have to subtract these two values because one is with zinc powder and second is after zinc powder was added to copper to sulfate. So subtracting these two, the value is 0.95 grams. This is the amount of zinc powder that was added to copper to sulfate. The student's results are shown. This is the time in minutes and this is the temperature that the student recorded. Part 2 suggests why no temperature was recorded at the 4th minute. As in the points, we have seen that the student adds zinc powder to copper sulfate at the 4th minute, so therefore he was unable to obtain the temperature. So we can write that the student was busy adding zinc therefore there is no observation at 4th minute. Part 3 suggests why zinc is powdered. Now powdered means we have large surface area and the reaction rate will be faster. Part 4 state why the glass beaker is not the most suitable piece of apparatus for this experiment, suggest an improvement. As in this experiment, the student is measuring the temperature, so therefore glass is not a good insulator. The student can use polystyrene cup instead of glass. Part 5, plot the values of temperature against time on the grid. On y-axis we have temperature, on x-axis we have time. Now the values for graph will be obtained from these results. We have time in minutes and we have temperature in degree centigrade. So putting these values in this graph. In first value we have 22.1 at 0 minutes. Now these are the time in minutes and on y-axis each small box is equal to 0.2. So 22.1 will be at this point. Then at 1 minute interval the value is again 22.1. Then at 2 minutes it is 22.1. Again at 3 minutes it is 22.1. At 4th minute there is no reading. At 5th minute it is 29.1. So this is 29.1. Similarly at 6th minute it is 28.9. At 7th minute it is 28.7. At 8th minute it is 28.5. At 9th minute it is 28.3. And at 10th minute it is 28.1. Part 6. Draw a straight line of best fit through the points from 0 to 3 minutes. So we have to draw this straight line. Extrapolate this line to the 4th minute. Now this is the line that is obtained from 0 to 4 minutes, extrapolated to 4 minutes. Part 7. Draw a straight line of best fit through the points from 5 to 10 minutes. Extrapolate this line back to the 4th minute. Let's draw the line. This is the line that is obtained and we have extrapolated it to the 4th minute. Part 8. Use your extrapolated lines to determine the temperature change at the 4th minute. Now we have to find the temperature change, which is delta T. So it is 29.3, that is obtained from this spot, minus 22.1, that is obtained from this spot, so 29.3 minus 22.1, the temperature change is around 7.2 degree centigrade. Part 9. Calculate the energy change Q in joules during the reaction. Use the expression shown. Q is equal to mass into C into delta T. Mass of solution is given as 25 grams. C is the specific heat capacity of solution, which is also given as 4.2. Value of delta T obtained from the graph was 7.2 degrees centigrade. So putting all these values, we can write Q is equal to 25 into 4.2 into 7.2. It is equal to 756 joules. So we can write 756. Part 10. The limiting reagent is copper sulfate. Calculate the number of moles of copper sulfate in 25 cm cube of this much concentration copper sulfate aqueous. We know the formula of concentration. It is equal to number of moles divided by volume in decimeter cube. So we can find the number of moles, which is equal to concentration in mole per decimeter cube into volume in decimeter cube. Now we can change this volume into decimeter cube by dividing by 1000. So now number of moles is equal to 0.5 into 25 divided by 1000. It comes equal to 0.0125 moles. Part 11. Use your answers from B part 9 and B part 10 to calculate the enthalpy change of the reaction in kilojoules per mole. Include the appropriate sign with your answer. From B part 9 we have this value 756 joules. From B part 10 we have this value 0.0125 moles. Now we have to find the enthalpy change of reaction in kilojoules per mole. So if 0.0125 moles produces 756 joules, then 1 mole would produce, let's say, X joules. By cross multiplying we can find the energy in joules. X is equal to 756 divided by 0.0125. It comes equal to 60,480 joules. Now we have to find the value in kilojoules, so we can convert joules into kilojoules by dividing by 1000. So it comes equal to 60.48 kilojoules per mole. Now for the sign, we know that after the chemical reaction the temperature was increased, so therefore this is exothermic reaction, and for exothermic reaction sign is always negative. So enthalpy change is minus 60.48 kilojoules per mole. Part C, the actual enthalpy change of this reaction is likely to be greater than the value calculated in B part 11, which is this one. Suggest the reason for this difference. Now in this experiment we have used glass beaker, which is not a good insulator, and also it was open, so therefore there is a chance of heat loss to the surroundings. So therefore due to heat loss, the value obtained is lower than the expected value. So we can write heat is lost to the surroundings.
Thanks for watching. A like, comment and subscribe will be highly appreciated. You can find related videos in playlists. Stay happy and enjoy learning.